Hello everyone, good evening, and I hope I am audible to all of you. So, let's just wait for another 2 or 3 minutes because many students are joining right now. So, then we'll begin with today's session, right? Hello everyone. I'm Ankita Bhatt from IIT Roorkee, and I believe I'm audible to you. I want this to be kind of an interactive session, where I'll get you help acquainted with the concepts that you have already studied in your lecture videos, and we'll try to connect it with real life scenarios. All right. So I'll just share my screen, and please let me know if it is not visible to any of you, or if you are unable to listen properly, right? And meanwhile, the lecture, if you have any doubts, so you can just drop it in the chat box, and we shall discuss it towards the end of the session. So I hope that the presentation is visible to all of you. Actually, there are some students that keep on joining.
Yes, ma'am.
I request all the students to please, from the next session, they should try to join at least 5
Yes, ma'am, it is visible.
Yeah, okay. Thanks, Satyam. So from next session, you all should try to. Yeah, I'm sorry. There is some kind of technical glitch here at the campus, I believe. Okay, so without any further delay, we should start with our today's lecture. So your first week's content was mostly dealing with the concepts of sustainability and ecology, right? So in this, I'll let you get acquainted with some of the concepts and elements. So it will be kind of a brief revision. And then my main focus in this session is to get you familiarized with life cycle assessment. So that is one kind of sustainability assessment method, right? And later on, towards the end of the session, we'll be having some QA sessions, and I'll be happy to help you with any of your doubts. So now this must be a kind of revision for you. So through the entire week and the earlier problem solving session that was held by Gautam from IISc, so you must have understood till now that what is sustainability, the basic idea behind it, and what are the elements or different concepts of sustainability. So it is just you have how you have to meet your own needs without compromising the ability of future generations to meet their needs, right? Now, the important thing in sustainability is when we talk about this, we have to consider all the three things. That is the natural, social, economic part, all the three aspects. And it is quite an old term. It was already given in 1987. This concept was brought to the limelight by Brundtland Commission. So when we talk about sustainability, you all know it is having three different components. One is ecology, one is economy, and equity. So that is basically called as the 3Es model, right? Now there is just a fact here. So like if you adopt sustainable practices, so it can really make a difference in the real life. So there is an example, you can see it in the right hand side of the screen. So it was estimated that if every office worker in United Kingdom used one less staple a day, if they're reusing paper clips and reducing the usage of staples, then approximately 120 tons of steel can be saved in 1 year. So this is just an example to show how your individual efforts, it can have impact at a very greater scale, right? So we also try to adopt sustainable practices, and it's not just should not just be restricted to the theoretical part only. So these are again some elaborations of the elements of sustainability. Like when we talk about environment, what are the different materials, energy, and biodiversity? So that has to be considered. Similarly, when we talk about the economical part, the capital expenditures or the technological growth has to be taken care, and similarly for the societal part as well. So basically, sustainability cannot be achieved until and unless there is a shift in decision making. So for
Ma'am, your voice is lagging so much.
yeah, so is that the problem for everyone or only for some people?
No, ma'am. Your voice is good, ma'am.
Okay, so so whoever was having that problem, that means there is a glitch at your side, right? So we'll just continue. Okay, so where were we here? Right. So we were talking about sustainability concepts. So initially, like any business proposal or any business was majorly driven by economical part. We are basically interested in how much profits and losses are we are going to make. So that was a part of the traditional decision making. There was no consideration of the impact of that process or that system on the environment or the society. But if we want to achieve sustainability, we have to shift from that method of decision making towards an ecosystem based decisions where we are considering all the three impacts: the society, economy, and environment. So we have to approach in a participatory and integrated way, right? So, and then like recently the sustainable development goals also have come up, the United Nations 2030 targets. So you all must have already been familiarized with this in your lecture. Let's move forward. So these are some of the sustainability facts. So I have just collected these facts from different resources to just give you an idea that how important this concept is, right? For example, if a hot water faucet it is leaking approximately 1 drop a second, then it can add up to 625 liters of water wastage in a month, right? Similarly, if you are running tap water for 2 minutes, so usually there are many people who have this habit of, like, while they brush their teeth in the morning, they usually leave the tap water running. So you see, if you're leaving it for 2 minutes, then that is equal to 11 to 20 liters of water it is getting wasted. So these are the practices. At these points, we can try to apply sustainable practices in our daily life. And similarly, if suppose 1 ton of 100% recycled paper is used, so that 1 ton is saving around 4100 kilowatts of energy and 7000 gallons of water, plus 60 pounds of air emissions are also getting reduced. So simple processes, they can add and give up to larger impacts. So the main focus of today's lecture, it is getting you familiarized with the sustainability assessment process or sustainability assessment method, that is life cycle assessment. So you must have already heard about this, and you'll also be learning some part of life cycle analysis in the second week module. So this will be just kind of giving you a brief glimpse of what is life cycle assessment. So see, nowadays LCA is very important. Whether you go for any process, you go for any technology development, at all the places LCA will be applied. And this can be important for you as well. You can go for such kind of LCA based projects in your undergraduate, postgraduate dissertations, or even if you're coming from a business background, you can apply these concepts in your this method in your field, right? So what do we basically do with LCA? So as the name suggests, it's life cycle assessment. So you have to analyze the impacts of a product or process throughout its life. So throughout the life means from acquisition of raw material. So how you are acquiring the raw material, what will that acquisition method will have impact on the environment, that you have to consider. Then you have to consider the production stage and the waste and disposable scenario as well. So by doing this analysis, you will basically get an idea about the environmental performance of that product or a process. So it can be done for both a product, process, or a system. So see, it can be clearly understood from the figure. You have to start from the acquisition of raw material, then how it is produced, what are the inputs and outputs during the production process, how it is getting distributed or transported to the end consumers, that will also add. And finally, after it has achieved its goal, like after it has been consumed or used by the target community, then what are the impacts that are associated with its disposal or recycling. So all these things go into the LCA part. So it is kind of a comprehensive and very complex process, but it is nevertheless very important in today's scenario. So the main aim is to facilitate. So what it does is it facilitates the identification of bottlenecks, like if there is some technology, so how that technology can be improved. Where is the major environmental burdens? So suppose if the burden is more in the extraction part, so you have to come up with a new technology or improve the existing technology relating to the extraction part. So basically, it helps you to identify the places where there is a maximum scope of improvement. Now this LCA concept is also not very new. So as you can see, it is coming back from 1970s. And earlier there was like absence of some common framework or a common methodology that can be adapted to do LCA. And the standardization was basically done in the recent times near 2000, right? So there is an international standard organization. So they have now defined a particular framework or a specific method or methodology that can be adapted to conduct an LCA for any your target system or process. So you can do the life cycle analysis of a simple object like a sharpener, okay, from its raw material acquisition, if it's made from plastic, how it is made, its use and disposal. And you can go up to big industries as well. So this is just an example to show you how broad the applicability of this technique is. So I hope now you have understood the basic idea behind like what is LCA. So now we will slowly and steadily move towards the methodology part, right? So now there is a standard methodology to conduct LCA. There are four main steps. You can see it on the right side figure. One is the is the goal and scope definition. So first you should be clear what is the goal of your LCA. Why are you conducting that LCA? Then what is your scopes, the study scope? Okay, so why are you conducting it and what all things will be included? Then the second is the inventory analysis. So inventory analysis is like if suppose we take example of a sharpener, right? So acquisition of raw material, production at each stage, what are the inflows and outflows? So if you're acquiring plastic, what is the inflow and outflow at that particular stage? So we have to create an inventory for each stage. So that comes under the second step, that is inventory analysis. So now you have the goal, you have the inventory. What you have to do? You have to conduct the impact assessment. So there are various softwares which are available for conducting LCA. Even there are open source like OpenLCA. Then there are some softwares that can be purchased like SemaPro or Gabi. And if you are really interested and you want to pursue this, you can try your hands on OpenLCA, right? And there are some models which can be developed in Excel as well. So after you have conducted the impact assessment through software or model development, anything, what you have to do is you have to interpret the results. So these are very four basic steps. First is goal identification. Second is you are creating an inventory. Third is you are actually conducting the LCA. That is you are converting your inventory into interpretable results. And finally, you are doing the interpretation part. I hope everybody is clear till now. So this again just tells about the applications of LCA. So there are very numerous applications. You can go for research and development, for product development. Then you can go for marketing and sales. There are different applications, and it is also quite very important for the policy making part as well. So we can see it is having applications in different domains. So as I was talking about the framework, so this is again a representation of the framework. Like the left figure, it tells you the four main steps. So we start with the goal and scope, right? So in goal and scope, there are three main parts. One is the functional unit, second is co-product allocation, and third is the system boundaries, right? So if you see the right side figure, so that is just an exemplary schematic. So this figure, the right side schematic, it just shows you a simple diagram of wastewater treatment plant. Okay, so it is beginning from wastewater collection, going towards primary treatment, secondary treatment, tertiary treatment, and we are getting the treated water. So I hope you all are familiarized with this. It's a basic wastewater treatment line. Then there are different things which can be considered in this wastewater treatment, right? Suppose your goal is to conduct an LCA of the entire treatment plant, that is construction phase plus the operation phase plus the demolition phase. Okay, so you want to see how much emission will be contributed during its construction, how much will be the emissions during its operation, and how much is the emissions during its demolition part. Then maybe, so according to that, your system boundaries will change. What are system boundaries? So system boundaries, basically you create a boundary around the unit processes that you want to consider. Okay, if I'm not interested in the construction phase, I want to go only to the operation phase, I'll just exclude that. So that will not be included in my system boundary. Okay, so depending upon your goal, you have to consider the different operations or processes that you will consider for your LC. Okay, so then in the second step, you will conduct an inventory analysis for each of these process. So the first thing in goal and scope, what we have to do is we have to define the aim. The second thing that has to be done is we have to define our system boundaries. The third thing is we have to describe a functional unit. Now, when you're conducting LCA, you want to obtain the environmental performance of any, suppose if we talk about a wastewater treatment plant. So you want to know the environmental performance of wastewater treatment plant. So now if I talk about environmental performance, what do we mean by that? So environmental performance means if it is treating X amount of wastewater per year, then how much GHGs are being emitted into the atmosphere? How much other harmful compounds are being released into the water if they're not getting treated, right? So the total impact of any harmful substance that can be there on the environment during the operation phase. So everything will be considered into this. So now if we want to get results, we have to get result in terms of a reference unit, obviously. So if I am talking about wastewater treatment, I have to get it in terms of suppose X meter cube of wastewater treated. So that is what is called as a functional unit. Functional unit is basically the reference unit on the basis of which you conduct the entire LC, right? So suppose for wastewater treatment, it can be for 1 meter cube treated water. If you are producing biofuel, if you are producing some kind of suppose some biomass based fuels, so accordingly it can be 1 liter of that fuel, right? So this is about the first step. So when we talk about the second step, which is inventory analysis. So here you can see I have written different terms like German Probas or Swiss EcoInvent or Australian LCI, US NCR, NREL. So these are basically different databases. Okay. So what do we do in inventory analysis? Suppose we are talking about primary treatment, right? Now, if in primary treatment, there is some X compound which is going into this treatment and there is some release of Y compound, right? So that X and Y, we have to create an inventory for that. We have to take them into account. So this is the example of inventory analysis. We have to create inventory for each step. So after you are having all the inflows and outflows for each step of your system boundary, we go to impact assessment. So there are different methods like TrackI, Recipe or CML. These are just names of different methods. So what do we do? They help you to convert your inventory into an interpretable result.
Hello, ma'am.
Yeah,
Sorry for the interruption, ma'am.
sorry.
But someone is joining, ma'am. My friend is asking for joining the class. Can you?
Actually, your voice is not clear. Is there any doubt? You post it in the chat box.
Some students also want to join, ma'am. Can you?
Okay, they want to join. Actually, see the limit here is 100 participants, right? So I'll not be able to add them, but this video will be posted in YouTube. The link will be posted so they can see the lecture there.
Okay, ma'am.
Okay,
Thank
I
you,
hope that works for you. Okay, so I think we should continue. Okay, so I believe we have almost finished this slide and I was able to convey my message, right? I hope you have understood the framework part now. Yes, so see, this is the example of impact assessment. As I was talking, you have certain inventories, right? Suppose you have for, right? So these are inventories. Just give me a minute. Yeah. So these are all the harmful chemicals like SO2 or particulate matter 10 mercury. Suppose these are getting released during primary treatment. Let's take an example, right? So now what can happen? This SO2, it can lead to ozone formation. It can lead to particulate matter formation. It can lead to ozone depletion. It has effects on various categories. Okay. So this basically, this entire thing, this is the example of recipe model, right? So I told you earlier here that we are having four different um, impact assessment methods. So this is an example of recipe. You can see it's written here. The reference is also provided. So what does it basically help you to do? It helps you to convert these harmful chemicals. It shows you the impact categories on which the impacts can be observed, and then finally they can also be converted into 3 more categories. So this part is called as impact assessment. You are actually assessing the impacts of the harmful chemicals or substances associated with your process or system, right? So here we have the inventory that is converting into midpoints, and this is converting into endpoints. So what are these midpoints and endpoints? It's just a nomenclature. So we have different midpoint impact categories. These are called as impact categories. So we have different midpoint impact categories where we get, if I want to know like what is the impact of SO2 on ozone depletion, so I'll go for the midpoint impact categories. But if I want to know what is the effect of SO2 on human health, then I will go to the endpoint impact categories. Okay, and there is a dedicated methodology for converting these inventory into this and then further midpoint to endpoint. Okay, so this is just to show you how actually we are interpreting the results. So similarly here also we have different midpoint impact categories and how these are getting converted into the endpoint. Okay, so depending upon your aim or what is the scope of your study, you can go for any of the kind of LCA. You can go either for midpoint or you can go for endpoint, right? So now I have taken example. This is a recent study from 2019. So I hope it will help you understand what I was teaching till now. And this will be really helpful for in any of your field. You can try to apply it and it's really interesting, right? So this is a research paper of 2019, and the LCA has been done for a wastewater treatment plant in Egypt, right? So this is a wastewater treatment plant, and they have done the LCA to propose improvement scenarios. So as I mentioned in the earlier slides, one main purpose of doing LCA is we have to see the bottlenecks, where are the limitations of this plant, then on we can go for we can develop for this improvement scenarios. That is basically kind of a technology development. Okay. So what they have done is they have given different improvement scenarios and then they have conducted the life cycle assessment and economic evaluation. So in today's era, environment and economics both has to be taken parallelly, and these are most important, the two of the main parameters, right? So after conducting both the assessments, they have finally come up with the best scenario. So LCA basically deals with your environment part, right? So this wastewater treatment plant, it is having a treatment capacity of 40,000 meter cube per day. And as I mentioned earlier, the functional unit is 1 meter cube treated water. So this is mostly the functional unit when we are talking about any wastewater treatment plant. So see, now this is the framework. As I was telling, now in this study, they are considering the construction stage and the operation stage, right? These two things can be considered. Then for the construction stage, now for each stage, you have to consider the inputs and outputs, right? So for each stage, they have considered the material and energy for the construction work, manufacturing, and so on. So different things can be considered. Similarly, in the operation stage, you have to consider the energy consumption, right? So this is a framework which has been adopted in this study. Now the system under studies, so this is the existing wastewater treatment plant. Then they have given 3 improvement scenarios. One is the existing plant, second is the existing plant plus anaerobic digestion, third is the existing plant plus tertiary treatment, and in fourth they have included both anaerobic digestion and tertiary treatment. Then they are analyzing the output in terms of gaseous emissions. So how much CO2, CH4 or nitrous oxide they are getting emitted from the treatment processes. For each process they will calculate this, right? And then they will calculate the overall performance. Then similarly the solid waste is sludge. Then the products are secondary effluent, tertiary effluent, biogas are digested. So this is just an example of a wastewater treatment plant, LCA of a wastewater treatment plant. There are you can do it for other processes as well. Now the database which they have used is EcoInvent2, and they have used the LCIA method of CML 2000 baseline method. So there are different methods and studies use different as per their their scope, their aim, and the availability. So these are the four scenarios which they have considered. This is the existing plant. So like these compile the primary treatment, right? Then we have here the secondary treatment. There is a disinfection tank, and the secondary effluent is getting discharged. So we see that in the existing scenario, there is no tertiary treatment. So tertiary treatment is basically where we are going for pathogen removal, right? So there is no tertiary treatment. Now the first scenario which they have given is they have integrated an anaerobic digestion process, and they are using the biogas which is produced from AD for electricity generation, and the digestate for fertilizer, using as fertilizer for agricultural use. Now in the third scenario, they have considered this tertiary treatment. They have integrated the tertiary treatment process, and in the fourth scenario, they have both the tertiary treatment process as well as the anaerobic digestion process. So in this way, people try to come up with different processes, and they try to compare the environmental performance. Now see, this is the example of the results. So how do we get the results? This is an example. Now they have displayed here only 8 impact categories: abiotic depletion, acidification, eutrophication, global warming, ozone layer depletion, freshwater aquatic ecotoxicity, terrestrial, and this, right? But as we saw in the earlier slide, if you recall, there are many impact categories, okay? So depending upon again your scope and area of study, you can display as per your requirement. Now, if I ask any one of you, or you should be able to judge by now, that what is the most feasible scenario. So we see green is scenario 1, then red is scenario 2, we have blue as scenario 3, and pink as scenario 4, right? So we can see that we are getting the most favorable results in the fourth scenario. See, in all the impact categories, this is getting the most favorable result. So in this way, we try to compare the different scenarios or different options which can be there, and we try to come up with the best scenario, and then we try to implement it in the real plant. Okay. So this is all about environment. If we are talking about the environment performance, but we have to consider economics also. So it should not be the case that the fourth scenario is very expensive, that it is not feasible to, add it to an existing treatment plant. So we have to consider economics as well. So after conducting the economics, they have observed that the best is the third and fourth scenario. Okay. So the third and fourth scenario can be best because here they are using the anaerobic digestion process also. So from anaerobic digestion process, they can go for electricity generation, right? So that is why these third and fourth scenarios are the best. And we already obtained that fourth scenario is best in case of environment also. So we can think of fourth scenario being implementing it at a larger scale, or checking its validity at a larger scale and performance, right? So this was just an example how actually an LCA is conducted, and what are the different points and flows that have to be considered in a study. So this was all for the LCA part. Now I have a couple of questions for you. So it will be nice if you could answer some of the questions. Like there are a total of 10 questions. 5 we can discuss it here, and 5 you can that will be your home assignment. So that we'll discuss in the next class. So what is the definition of sustainable development? The growth that satisfies current demands without jeopardizing future generations' ability to fulfill their own needs, or conserve mineral wealth and explore alternative energy sources while decreasing pollution and environmental impact. Or it is the process of creating land and building projects in such a way that they have a lower environmental effect by enabling them to produce fuel efficient and self-sufficiency patterns. So you must have understood for the sustainable development part till now. So I hope to get answers from some of you. And this is supposed to be an interactive session, so I would appreciate you people responding to the QA sessions.
On the board.
Sorry.
All of the above.
Yeah, right. All of the above. So I hope everybody has understood. And if there is any doubt till now, you can just unmute yourself and ask, or you can post it in the chat box. I'll just check if there is any question in the chat box. Yeah, you see, I cannot. Participants are not alone. Okay. Yeah, so somebody has written C, C, D. Okay, so I think despite so many lectures on sustainability, the correct meaning is not yet understood because I see some people responding to the third option as well. So, see, if we talk about sustainable development, first is that satisfied current demands without jeopardizing future generations' ability. So, I hope instead of C, I could have at least got A, as the incorrect answer, as the answer. So the first one is obviously true. You have to use the resources in a way that your future generation's ability to use that resources is not hampered, right? Second is conserving mineral wealth and explore alternative energy sources. So that is again going to uh, resource conservation part. So you are again exploring alternative sources so that your future generations they have this they have the ability to utilize the resources, right? And third is also again going towards sustainable development. Yeah, I think there is. Yeah, I request you to please keep yourself muted if you don't have any question. Okay, then again the third option is you have to go fuel sufficient and efficient manner, so the answer will be all of the above, right? Now this is the second question. What is the purpose of a life cycle assessment? To assess the environmental impact of product, to assess the financial cost, or to assess the time it takes to produce a product. So, and some of this content and questions can come up in your final exams as well. So I hope you all will be
Ma'am,
okay. Okay, so for this, most of the people have. I believe there are only 4 to 5 students who are active because only they are responding to the questions. Okay, fine, good. So the answer to this is A. Okay, then the third question, which of the following is not included in a LCA? Okay, impact of extracting raw material, impact of making the product, impact of disposal, or all the answers are included.
all the answer.
D, ma'am.
Okay,
D, ma'am.
okay, so most of you are answering D. So I think the today's session was fruitful because most of you are giving right answers, or maybe you already have the idea of the concept, right? There can be only two things. Okay, now coffee cups are made from ceramic, glass, paper, plastic, or metal. Okay, so some of the materials are recyclable. In a LCA, where would this information be given? So where would the information regarding the recyclability of these materials will be given? During extraction and processing, during the disposal of cup at the end of its useful life, so when the cup is manufactured and packed, or during the use and lifetime. So if we are talking about the material of any product, so and we are talking about its recyclability, so at what stage of LCA this information will be given? So that is what the question is. Okay, let's see if somebody has answered. Okay, you just write question number in front of your A, B, C, D, whatever you are typing. Satyam, write question number in front of your answer. Okay, we have 4B. I see there is some doubt regarding this question. Okay, I would like you people to read it again and give it a 2-minute thought. because till now the answers were correct. So I hope you all to understand this and give me the correct answer. Some of you are giving the correct answer, but I just want others also to give it a thought and answer me again. Okay. When will we be talking about the recyclability of the material? So there are all kinds of options coming in, A, B, C, D. Okay, so see, when we are talking about recyclability, so this extraction, this extraction is the first stage. Okay, the processing or production is the second stage. Then it comes to use, or it can come to this manufacturing and packaging. So this is second or third stage, right? Then it comes to the use, which is the fourth stage, and disposing is the final stage, fifth part. Okay, so when will you talk about recyclability? You will talk when its life is over. Then only you can recycle it, right? You will not recycle it in the beginning. In the beginning, you are having the raw material. You will recycle it after it's been used. When do you recycle empty glass bottles or jam bottles? Okay, you recycle it when they have been used. So when we are saying mentioning about recyclability, we will use it after the end of its useful life. Okay, so the correct option is B, and I believe now you have understood it's not A or D, it's B. Okay, because we talk about recycle after the product has been used till its entire life. Okay, so let's go to the fifth question. Which of these is an important factor to be considered when doing an LCA? Opinions on branding, energy used during manufacture, age of the technology, or percent profit made by selling product. Just give it a 2 minutes thought. Don't answer it directly. Read the question carefully, understand it, and then provide me the answer. Okay. So what is important to be doing when doing an LC? You have to consider the energy use, or you have to go into the branding or the age, what is the technology age, or the profit percent which is you are making by the system or the product. Okay, so let's see the answers. Okay, so two students have replied. Okay, so I see you all are understanding the concept very well. Okay, so that's nice. Yeah, okay. So most of the students have given the correct answer. It's B. You have to consider the energy use. Okay. So then we go to the sixth question. Which of these is not a stage to be considered in a LCA? Cost of advertising the product, obtaining raw materials, manufacturing or disposal. So what is not to be considered? Let me see if we have any answers. Okay, so everybody is confident that cost of advertising the product will not go into an LCA. Fine. Then I believe that's the right answer. Now the first stage of LCA involves extraction and processing of raw materials needed to make a product. Which of the following raw materials are renewable? I think this can be easily answered by all. So which of the following raw material is renewable? Wood, crude oil, minerals or metals? So which among these is relatively renewable? Okay, so one student has responded D. They believe metals is renewable. Fine. Okay, so I'm getting different kinds of responses for this answer. So I'll leave this question to you and we'll discuss it again in the next class. Okay, there are, okay, everybody is giving all kinds of options. Fine. So mostly we have some confusion between wood and metals. So I hope this should be easily answered by you. It's a very basic question. Okay. So this seventh question we'll leave and we'll discuss it again next time. Now the eighth question is, scrap iron is melted down and added to new iron. So what is this? This is an example of reusing, recycling, reducing, or none of the above. So you can just note down the questions from 7th to 10th question. We'll discuss it in the next class, right? But I can still see if you are answering to some questions. Okay, so we still have different opinions for this question as well. Okay, so I'll just, wait for 1 or 2 minutes. Just take a screenshot or note down the question. One is this, the LCA first stage involves extraction and processing of raw materials. So you have to identify which of the following is renewable. Wood, crude oil, minerals or metals. Then the next question is scrap iron being melted down and added to new iron. So this is an example of reusing, recycling, reducing or none of the above. So whether we are reusing the iron, recycling it or reducing it. So you must have studied the 3 hours or now it is these are the 4 hours. So then the next is you have to identify the life cycle stage. Okay. So for each process, you have to give me an answer like what is the LCA stage, whether it's production, it's use, disposal, recycling, at which stage what these images are depicting. So you can just take a screenshot or the lecture will also be available on YouTube. You can go through it and you can check these questions again. Okay. So moving forward, so I believe this is the last question. A company produces a C commodity from A raw material. So we have an A raw material and a company is producing C from this. Okay. 60 units of A are required to make C. It takes 25 kilojoules to make 5 units of A. How much energy is required to make 60 units of A? So for conducting an LCA, you need to create inflows, outflows, then you have to have material balance and energy balance. So this is an example of unitary method, which is mostly very commonly applied. And even if you are an undergraduate student, I believe you will be easily able to solve this. So I'll just explain your question again. We are producing C commodity from A. If 60 units of A are required to make C, so we require 60 A to make C. And to make 5 units of A, 25 kilojoules energy is required. So how much energy is required to make 60 units of A? Okay, this is the first part of the question. You have to calculate if you want to make 60 units of A, how much energy is required. And you are provided with this information. Now the second part is, if 1.25 units of B are also to be added. So now initially you had A, now you leave this part, okay? You come down to the second situation where you have A plus B, which is giving you C, okay? And you want 1.25 units of B. Now for every 1 unit of B, you are getting 2 grams CO2, which is being emitted to the atmosphere. So you have to calculate how much CO2 will be emitted for 1.25 units of B. Okay. So this question is in two parts. First, you have to calculate how much energy is required to make 60 units of A. And in the second part, you have to calculate how much CO2 emission will be emitted for 1.25 units of B. Okay. These are two separate parts. Don't get confused with them. And if you have any doubts, we'll again discuss it in the next session. So I hope everybody has noted down the questions. I'll just scroll through them once again. You can take a screenshot and anything if you have not noted them down. So we have the 7th, 8th, 9th and the 10th question, which we'll be discussing in the next class. Now this is an assignment for all of you and I expect you to do it and I will discuss it in the next class, especially from the participants. I see that all of you have participated very well in today's lecture. You have responded very promptly. So the question is, how can you contribute towards achieving the SDGs? So we all talk about United Sustainable Development Goals. There are 17 goals. You have to save water, you have to provide clean energy, and so on. So what are you doing as an individual to achieve the SDGs? Okay, so you are students, you cannot go up to the policy making level. So what are you doing as students or individuals? How you can what are the measures or practices which you can adopt in your daily life to achieve the sustainable development goals? So reading a subject in the theoretical part is one thing, but how you can actually apply it in your life. So I want each of you to write at least 5 points, 5 to 10 points, and then we can consider it as a home assignment. Then we will see in the next class what we can all do, for this part. So thank you for joining the today's session. And if you have any doubts, just post it in the chat box or let me know. You can unmute yourself and ask your questions. Okay, I see students have still responded to the questions. Never mind, we'll discuss the 7th to 10th question in the next session. Okay, so if anybody has any doubt, you can ask or just post it in the chat box. Otherwise, we'll conclude with today's session. Yeah,
Okay, ma'am. Thank you.
okay. So Satyam was very interactive in the entire class, and now he doesn't have any doubt. He has understood everything, right?
Yes, ma'am.
Okay, Satyam, I'll ask you the last question which I have given, like how you can contribute for SDGs. I'll ask you. Okay, there is one
Okay.
doubt. Can you repeat the assignment? See, you can go through the lecture because there is already 2 to 3 minutes left. So you can go through the lecture. It will be posted on YouTube, and you can check the assignment there. You can again visit the presentation as well. And if you have any doubt, then you can again ask in the next session. And you'll also have another interactive session on Friday. Okay, so by Gautam. So please remember to join that. Okay, so if we don't
Shall
have
we
any,
leave now, ma'am?
sorry.
Can we leave, ma'am?
Yeah, you can leave. Okay. Thank you for joining. So you can leave.
Okay. Thank you. Thank you, ma'am. Thank you, ma'am.
Okay,
Thank you, ma'am.
sure.
Thank you, man.
Okay. Thank you.
Thank you, ma'am.
Yeah, thank you.
Thank you, ma'am.